This is problem number 2 on the sample test problems for test number 3. Consider the function f of x equals e to the negative 2x. A, find the local linearization of f at x equals 0. Okay, so it turns out there is a fancy formula for the local linearization. I don't necessarily remember it, but maybe it's something like this. Where a is the point that you're focusing on. In this case, it's x equals 0. But I'm not such a fan of fancy formulas, so let's just go back to first principles. Local linearization is a synonym for a phrase we've been using all semester. Local linearization just means tangent line. So this problem is just asking us to find the equation of the tangent line of that function at x equals 0. So to find the equation of any line, we need two things, a point and slope. So let's find the point first. So the point in this case is at x equals 0. So to find the y value, we'll plug 0 into the original function. And anything to the 0 is 1. So in terms of coordinates, the point that we just found is 0, 1. The other thing that we need is the slope. So the slope is now where the calculus comes in. So to find the slope, first we'll take a derivative, not at 0, but at a general x. All right, this is e to the negative 2x. That's a chain rule. E to the stuff becomes e to the stuff times the derivative of the stuff. So that's our derivative. We are interested not in the general derivative, but in the derivative at x equals 0. So we want f prime of 0. And again, e to the 0 is 1, so the slope here is negative 2. So now we'll just put it together to come up with our formula. So we can use y equals mx plus b, although to be honest, the fancy formula in the book probably came from the other version of a line that we've talked about. Either way is fine. Sometimes actually the top equation I just wrote in black is better for linearization. In this case, it won't matter. So in our case, we have y equals the slope we just found is negative 2. Still trying to find the y-intercept. In this case, it's a gift. It's given to you as 0, 1. So the local linearization here is negative 2x plus 1. So what that means is that our function, e to the negative 2x, is roughly given by negative 2x plus 1 for x is near 0. Part B, use the local linearization to estimate f of 0.01. So I guess the question is asking us to plug 0.01 into the function. So f of 0.01, according to the definition at the top, e to the negative 2 times 0.01, e to the negative 0.02. I have no idea what that's approximately equal to, but we can use our local linearization to estimate. So let's try that now. So if we use this thing right here and plug in the same x value that we just had, 0.01, that was the x, negative 2 times 0.01 plus 1, this is something we can do quite easily. So that's a negative 0.02 plus 1, which is a negative 0.98. And by negative, I mean positive. So 0.98, that's our estimate. That's our answer. We're done with this question. The idea is that this is hopefully something not too far from 0.98. So now in part C, it says use a calculator to compute the error in your estimate. So to find the error, what we should do is figure out what e to the negative 0.02 is from the calculator, and then subtract off our approximation, which is 0.98. So we'll type this into the calculator. So e to the negative 0.02, I'm just going to hit enter here. I want to know how close we were. We're looking for something right around 0.98, and that is pretty darn close. So that's the number from the calculator. If we subtract off 0.98, our estimate, then we get the error, which is so small that the calculator is reverting to scientific notation. So let's go ahead and put it in. So this is approximately 0.9801, and then some more stuff, and then minus the 0.98. And so that is approximately, and then we'll grab this from the calculator with a few more digits. So let's see, that e to the -4 means take the decimal place and move it 4 places left. 1, 2, 3, 4 means how many zeros are there? I think that means there are 3 zeros there in the front. And then 19867. Three zeros in the front and then that number. And that is a very small error.